Good morning, everyone. We're admitting all the folks waiting in the lobby to join the webinar today. So just give us a few minutes here just to allow some last-minute attendees to join into the webinar, and we'll get started in just a minute or two. But while we're waiting, I just want to remind you, today's a big day for IWCS. We have reached the deadline for abstracts to be submitted for technical papers at the 2023 Cable and Connectivity Industry Forum, which takes place in Orlando this year in September. I'll give you more information on that towards the end of the webinar. But if you have any last-minute abstracts that you want to submit, it's a very simple process. If you go on the IWCS.org website, you can easily submit an abstract. So don't be intimidated that we're at the deadline day. We'd sure love to hear from you if you have any thoughts on what you and your company is working on and can share with the industry. Again, it's a good way to promote the activities that you're involved in. So. Still looking for any last-minute abstracts, and we appreciate you participating both in the conference as well as in the webinar today. So let's just wait just a minute or two more. Okay, why don't we go ahead and get started? There may be one or two last-minute attendees joining, but welcome to today's IWCS webinar event. My name is Dave Cadu, and I'm honored to be the CEO and Director of IWCS, and I'll be your moderator for today's IWCS webinar series event. A few housekeeping items, just to remind you that as an attendee, you're part of a larger audience, and during the presentation, all participants will be in listen-only mode. And also, as a reminder, this event is being recorded for rebroadcast, and we will be uploading it to our website for viewing shortly, within a week or so. Just be respectful of that. We encourage you to submit written questions at any time during the presentation. While Pravin is presenting, use the chat panel on the right of your screen. After typing in your question in the space at the bottom, please hit the send button, and your questions will be addressed, time permitting, at the end of the presentation. Our IWCS series event is hosted by the Cable and Connectivity Industry Forum. And today we welcome Pravin Rajeshwar, who is the modeling project leader at Corning Optical Communications in India. We had to have a last-minute substitution, but Pravin is well versed in this presentation, so we look forward to an excellent presentation. Pravin will be presenting his paper on the impact of modifications in external air supply on the EN50399 cable burn test. Pravin received his master's degree in mechanical engineering from the Indian Institute of Technology in Delhi, and he worked at ANSYS as a consultant for computational fluid dynamics applications. And here his work was focused on modeling combustion and flames for various applications, including IC engines, gas turbines, etc. He joined Corning Research Center, India, as scientist in 2014, and currently his work is focused on designing flow and thermal processes for various Corning businesses. So we welcome Pravin to today's IWCS event, and thank you for this excellent presentation.
Thank you, Dave, for organizing this event, and all the best for the people who are going to submit the abstract for the next upcoming IWCS conference. So my topic of today's presentation is impact of modification in the external air supply on the EN50399 cable burn test. And I have a list of collaborators mentioned here. My name is Praveen Rajeshirke, and this work was done within Corning as part of the marketing strategy. And the same was presented in last IWCS conference back in October 2022. So here is a brief agenda of my talk. I'll briefly introduce the problem that we are trying to solve. And later on, I will talk about the variation in cable burn test across various labs across the European Union region. And briefly mentioned about previous investigation that was done on this topic and the current work as part of this study. Okay, so in this slide I have information related to this particular test EN50399. But before going into that, I will briefly talk about the CPR regulations. So CPR lays down harmonized rules for marketing of construction products in the EU region. So these are set of rules that all the manufacturers have. These are set of tests that all the manufacturers have to undergo before they can market their products in the EU region. The regulations provide common technical language to assess performance of construction products. It ensures reliable information is available to the customers on the performance of the products so that customers can make informed choices when they buy these products. So the idea of CPR is to provide reliable information to customers so that they can make informed choices. One of the very important information that people need to know before they can buy the construction products is the fire survivability of the products. And this particular test is about fire survivability of the cables when they are installed in the construction environment. So all the cables which need permanent installations in EU region must be classified as part of this test. Cable classification is determined by the standard. It's a kind of a document which lists down all the procedures, test procedures, and the test chamber design that can be there for testing the cables. Key parameters that are tested as part of this particular test is flame spread. So flame spread is basically how long the flame travels along this particular ladder that is mentioned here, that is shown here on the right hand side picture. On the right hand side picture. And during the test, they also measure something called total heat release rate. This is the amount of heat that is released during this whole burning process. And these are, I have listed down just two of these products. They also measure something called smoke release rate as well. So combined with flame spray, total heat release rate and smoke, that is the main detrimental factors which make harm to property and human beings inside the construction area, inside the properties, right? So these are the three main things that the test captures. This particular test gives classification shown in this particular block, starting from B2 classification all the way up to F. The classification for A and B1 is done through another test. So here I have a small schematic. It's not, it doesn't show all the details of the test chamber that is used for testing the cable burn performance, but this shows the key features. So we have a sort of hexagonal shaped, quadrilateral shaped test chamber, and it has two one inlet on the bottom side for air to come in, and one outlet on the top side through which the combustion products can go out from this chamber. So that is the feature of this, and along with that, all the combustion products that go out from the test chamber, they are collected and are sampled. And in this sampling tube, this is where they measure the heat release rate, smoke production rate, and all of the key parameters. The cables are typically mounted on a metallic ladder. It is usually made up of steel, and depending on size of the cable, they are either bunched in few numbers together, or they are mounted one single adjoining to each other. The test itself starts with starting the flame, starting the burner. The test itself starts with fire provided by the burner. It's placed somewhere here, and this burner creates a flat flame which impinges on this cable, on these cables. And then once you initiate the fire, it is supposed to propagate along the cable length vertically upwards. And based on the cable performance, it will propagate a large distance or a small distance, and that will decide the classification of the cable. So in this particular work, we are more focused on the air supply that comes out from the bottom, from the floor of the test chamber. This particular outlet is again connected to a set of tubings which supply the compressed air through these tubing systems, and then at the end of this, it comes inside the chamber. Okay, now I'm going to talk a bit about why we are testing, why we are studying this particular test. So the topic of the next part is variation in the cable burn performance. So this is the main problem that we are trying to solve. So there are various labs across Europe which do this test and can give classification to the cables. And the manufacturers are supposed to reach out to these labs for getting their cables classified. And we also in-house have a lab, have a burn test chamber in Berlin. And what we have found is that the test results are not reproducible across the labs. So if you do this particular test in one lab multiple times, you will get similar results. But if you do this test across many labs, then the results are not similar. So the test is reproducible at one lab, but not replicated across the other labs. So that is the main problem. And we wanted to see the difference between each of these labs. What is the difference in the test procedures that they adopt, or what is the difference between the test chambers that they have. So to do that, what Corning, as one of the leading optical fiber and cable manufacturer, we took the initiative and provided a standard cable. We call it a standard cable. It's a dummy cable which doesn't have fibers inside it, but it can be. It's a very simple design. It can be used for. I have more details on the next slide, but that is what we used for testing all of these labs. The results across these labs. It's easier to compare them using one standard cable. And it was found that across these labs, the test results were giving a certain flame spread numbers with a certain spread, and that was not consistent with what we had in-house at CTCB. And our test chamber gave a lot higher flame spread values than flame spreads reported by these accreditation labs across Europe. So that was the main motivation behind this work. We wanted to understand what is it that governs the flame spread values in this test. So as part of that, we have done a lot of work in the past. In this particular presentation, I'm only going to talk about the effect of the air supply system on the flame spread values. Otherwise, in the past, we have done studies on burner feed rate, chamber insulation, chamber design itself, the cable design itself, how we mount the cable. So there were a lot of studies done in the past. I'm not going to go in detail of all of those studies, but you can find a lot of that information available on previous IWCS presentations. So I briefly talked about the reference cable that Corning took an initiative to build. This particular reference cable has a flame retarding jacket material on the outside, a PE element in the center of it, and then the GRP element, strengthening element at the core of it. So this particular cable was used for was provided to all the labs across Europe to test. And then it was easier to compare because we had provided the same cable across the labs. I mentioned about the previous studies that were done, and one of those studies was related to burner feed rate. And we do that the burner feed rate study was done to just verify the input, verify that the fuel input can be accurately measured by the devices that we have installed on the test chamber. So it was very consistently verified across very long duration of time. As part of this round robin study, we also found that the flame, it was difficult to test the flame or compare the flames that are produced by each of these burners. So as this kind of a blackboard, wooden blackboard was used to compare the flame structure across these labs, the flames produced by each of these labs, and then based on the outcome of this whole study, we it was decided that anything that falls within this region is acceptable, and there was a wide range of flames that were accepted, and certain criteria were devised about the flame. And we want to do something similar for the air supply system as well. So I'm now going to talk about one of the previous studies that was done on air supply system. In 68th IWCS conference, me along with some of my colleagues presented a study on a hypothetical scenario where we modified the air supply system by putting in a kind of deflector shown here, and this created asymmetric flow, asymmetric air supply inside the system. And at the end of this study, we found that this asymmetric flow pattern leads to lower flame spread. And then this led us to further improve, further do or explore this air supply system more to understand exactly what is, how does that impact the flame spread. Then in the later studies, what we did is we closed the half portion of the plenum or the plenum box. In one experiment, we did it towards the door side, and in another experiment, we did it towards the cable side. And what we found is that when we covered the plenum towards uh, the door side, the flame spread was drastically reduced from 1.9 meters and went down to 1.6 meters. So this is large enough to make changes in the classification of the cable. So this was significant impact. And both of these changes um, were very easy to spot if you look at the chamber. So it was not obvious if someone wants to someone modifies the chamber according to these suggestions, then it was easier to spot and anyone can figure it out. So this gave us some more understanding that there may be other things that are hidden inside the plenum box, which create similar flow patterns. And at the end of the experiments, we might end up getting smaller flame spread. But we don't know that the reason for smaller flame spread is the air supply system and not the cable design itself, which we really want to test. So that was the motivation. So next, we again looked at the air supply system in more detail, especially the region which is hidden beneath the floor of the test chamber. So below the so and this schematic shows the air supply system that is hidden beneath the floor of the test chamber. And this particular phase is opening inside the chamber, which is providing the air supply inside in the chamber. So we cannot do any change here, which is visible to the naked eyes. So we looked at if we do changes inside the supply lines and make a flow pattern, airflow pattern, something similar to what we saw in the previous slide, we might end up getting reduced flame spread. So that was the main motivation. So to see if uh, things modified here can result into lower flame spread. So the rationale behind this test is to check the design of the cables for reducing the flame spread rate. It should not be it should not get impacted by the test the chamber design. So this is one of the things we wanted to study. Then we identified these modifications in the underfloor and its impact on the flame spread. And this we expected that at the end of this test we will alter the flow distribution in the chamber, and that will ultimately impact the flame spread. And let's see some of the results what we got. So the flow distribution, these are the plots I'm showing here are of velocity, more specifically vertical velocity on the phase that enters the um, enters the chamber, and with the three this one the A figure is the standard one, and the bottom two are the modified two modifications that we tried, the bottom blocked and the top blocked picture. And because of that, we already saw that the air supply was modified. It was more modified for the top blocked system, and this gave us more confidence that this is going to now impact the flame spread drastically. And it was also verified through experiments as well. We experimentally also found out that the top block portions, the top block case was more impacted for the changes in the velocity than the other two cases. Now I'm showing some streamlines of the air that comes in through the plenum box. So as I said, the supply line is hidden beneath the beneath the floor. So if you're looking from the door, you won't be able to see this because this is below the floor. And once the flow enters, there is a small angle deflection towards the bottom side, which forces the uh, air towards the downside, and it takes a U-turn in this block, and because it is forced in the corner, it has to take a U-turn because there is no more flow, no more path for the flow to go further. So it takes a U-turn and then it directly uh, travels towards the cables. So this is where the burner and the cables are located, and it cools down the whole system here. And because of this cooling down effect, direct impingement of this colder air towards the burners and the cables, we end up getting reduced flame spread. So that is the whole mechanism. That doesn't happen for the standard flow setup. And even if you block the bottom side, this particular case, uh, it doesn't create this kind of pattern because the flow, if you block the bottom side, the flow can travel from the top portion open here, and then again it will create similar flow pattern, and you will end up getting similar flame spread. So that was the main factor deciding the flame spread. So here I have some experimental evidence to support the hypothesis that I explained in the previous slide. So for standard air supply, we get a flame spread close to 1.9 meters or so. And with the bottom blocked supply, we again end up getting similar kind of flame spread. But with top blocked system, it's we end up significantly getting reduced flame spread. It is reduced by about 0.4 meters, and that is large enough for influencing the classification of the cable. Uh, so we also measured how the air supply system in the chamber gets affected by measuring the exact velocities at different locations. I'm just showing 3 of these measurement points, and we can clearly see that for standard, at all the flow goes towards the door, and that creates high velocities near the door, about close to 1.34 meter per second. And then at locations 2 and 3, 3 is close to the burner, we end up getting reduced velocity. But for top block case, the airflow near the door has lower velocity, 0.4 against 1.34, and but near the burner or towards the burner, we get slightly higher velocities. So more air is supplied towards the burner directly rather than traveling along the door. So this is the main mechanism which reduces the flame spread, and helps us, get reduced flame spread. And this is something we should avoid because we want to test the cable's performance, not the test chamber's performance. So any modifications that are done underneath the chamber are going to affect the cable burn performance. So the standard document needs to be modified to avoid such scenarios. Okay, to summarize, I would say the flame spread results from round robin tests that was done across the EU labs showed lower flame spread than CTCB. CTCB is the lab in Berlin, Corning's lab in Berlin. And this impacted the cable CPR classification. The air system found as a critical factor in the past, and further investigation of this air supply system, it shows that in this particular work, we did further modifications to the underfloor air supply duct and studied in this work. This underfloor duct modification can significantly impact and reduce the flame spread. Not only the flame spread, but also heat release rate and the smoke production rate along with it. However, this modification is in violation of the standard and should be avoided. And variation in the air supply can be identified experimentally, and that was also done as part of the study. All right, so that was mostly it from my side. So I can these are some of my collaborators as who have done lot to help me do experiments and also do technical discussion across last few years. So I would like to thank them and thank you for your attention, and I'm open for any questions if you have any.
Pravin, thank you very much. Extremely informative and very helpful. The fire safety performance of different cable designs is essential in network applications, building applications. So this is very valuable information. Well, most of your testing, and this particular test is a vertical test. I was curious to hear of the underfloor scenario, the evaluation. And you even, in fact, use the term plenum chamber just as far as configuration is concerned, which raised the question, while the plenum test, the horizontal plenum test, the NFPA 262, has higher airflow and higher fuel content to the flame. Do you see any correlation capabilities? Have you even evaluated the same parameters so that we can begin to find a correlation between 50399 and the horizontal plenum test?
Yes, the horizontal plenum test, it mostly is used for not for the complete design of the cables, but for specific material samples. At least that's what we do within Corning, that I'm aware of. So we do see correlation between the two. For example, if we have a material which gives out a lot more heat release rate in the plenum test, horizontal plenum test, then we end up seeing something similar in this particular test as well. So there is definitely some correlation, but physics-wise, if you look at the vertical flame test, this scenario is more applicable or is more closer to the fire incidences that we see across the globe. So the fire incidence within the buildings, the fire usually travels vertically upwards. So this particular test governs that scenario more accurately than the horizontal plenum tests.
Well, I think that it's helpful to continue to research that because obviously, the horizontal scenario, there's obviously a significant amount of cable installed in the horizontal scenario versus, the vertical scenario. But clearly, any correlations we can make are helpful. For top blocked airflow, what is the effect on the flame shape? Is it still the correct flame shape?
Yeah, the flame shape, I guess you're meaning the flame shape, whether it remains symmetric or gets asymmetrically inclined. So yeah, the flame shape remains symmetric, but it is reduced drastically. So for example, this one, the standard and the bottom blocked cases, we end up getting flame spread close to 1.9 meters. And for the top blocked case, the flame spread is reduced to 1.5 meters. So it's a 0.4 meter reduction. And if I go back to so we don't have the numbers here, but the 0.4 meter can change the classification of the cable from class C to class B to, or yeah, vice versa.
Very good. And Following up to the original question, a few more of the same vein, the CSA FT4 or UL 1666 riser in North America, the IEEE 1202 flame tests, all being vertical and of similar configuration and airflow and fuel to the fire. Do these tests really compare? I mean, again, is there some sort of correlation? Obviously, we would like to understand as we design cables and materials to have some consistency. So have you seen any correlations to the other vertical tests in CSA or UL or IEEE?
Yeah, so most of the cables that perform well in one standard, for example, EN50399, that design does well in other standards as well. So there is definitely a correlation, and the tests are a bit similar. There are differences, but physics-wise, they are more same than different. So yeah, we do see relation between them. Thumb rule is that if the cable design does well in one test, it should do well in the other tests as well across the other regions. Yeah.
Yeah, very good. Among all the variables that Corning has studied, which ones have the greatest impact on the burner behavior, flame spread or heat release rate? Is it possible to rank them from highest to lowest as far as impact is concerned?
That's an excellent question. So we end up, as part of this work, we ended up studying probably hundreds, uh, if not 100 more parameters. So the obvious ones were the burner flow rates, burner flame patterns, burner flame shapes, temperatures, burner temperature, flame temperatures, and all of them. And the initial inclination was that burner is one of the main factors governing the flame spread. It is main factor, yes, but we have come to a conclusion now that along with the burner, the air supply system also plays major role in governing the flame spread, as was shown as part of this work.
Yep. Very good. Were there any indications that the laboratories that were participating in the round robin evaluations were modifying the air supply box?
I'm not very sure. I have not visited all of the labs. There were obviously differences between the labs, small differences here and there, but I can't comment whether they were made intentionally or not to affect the test. They were there as part of the chamber design itself, I guess.
Okay. Yeah, that's always a question. I mean, the test is very sensitive, and so consistency is critical, clearly, to get the same modeling and evaluation of the cables. Did you happen to check the flame shape when changing the plenum air flow each time? And according to the new standard, would this be an indication of any problems?
Yeah, so I understand that in the new standard, there is going to be some modification in the way the flame shape and flame sizes are produced. I have not seen the new draft yet, but I think 2 or 3 years back, there was a round robin study across the labs to check the flame shapes. And it was observed that there was a lot of variation in the burner flames. And it was at that time decided that there was some need to quantify the flame in some way, at least the shape wise, and have that included in the standard document as well. So as part of that, I think these are some of the things that I have listed here are now going to be part of the document.
again, the dimensional and flow consistencies are critical in any flame performance
Yeah.
testing.
Yeah.
So we'll obviously all the labs have to be recognizing that for consistency. Is there any effect of air temperature, and was that considered?
Yes, we did study air effect of atmospheric conditions, air temperature as well as humidity
Yeah.
of in the air. But we have found that those do not affect a lot. Obviously, if you have higher atmospheric temperature, air temperature, you end up getting slightly larger flame speed, but it is statistically it is insignificant. So air temperature does not play a role.
That's good to know. Well, a lot of good questions, and we thank the audience for submitting your questions. And again, Pravin, we can't thank you enough for providing this excellent presentation. It was very well received at the conference in 2022 and in previous conferences as well. This topic is continuing to provide tremendous information so that cable designs and materials can improve accordingly. So again, please note the contact points for Pravin. And should you wish to contact him after today's event, each, again, of these IWCS webinar presentation events are recorded and will be archived on the IWCS website. Normally takes up to a week or two for these to be posted. The IWCS webinar series will continue to conduct its technical paper presentation webinars and also some sponsored company events each month. And our next scheduled technical paper presentation event will be on Friday, May 19th at 10:30 p.m. Eastern USA time. We try to be consistent, by the way, the third Friday of every month. Each of you will be receiving an announcement for the event, so please feel free to share our announcements with your colleagues so that they can register as well. Again, a reminder, today is an exciting day for IWCS. Today is the deadline to receive technical paper abstracts for the upcoming 2023 conference in Orlando, Florida. So again, we'd love you to share your innovations and your research to our global community for the betterment of our industry. So if you have an idea to submit an abstract, it's a very simple process. It shouldn't take too much of your time to summarize what you would like to present. You can go on to our iwcs.org/present, and you'll see all the instructions. It's again, we try to make it as simple as possible, but today is the deadline, so please consider that one last time. Let me just ask Michelle, any last questions that may be out there for Pravin?
Yes, I think that two came in while you were speaking. One from Kiki Chen. Can you share the directory to the study that compares the cable design if they are available online? That was the first question.
Okay, yeah, so the lot of the previous studies on various other parameters have been presented as part of the IWCS conference. So if you visit the previous paper directory at IWCS, you should find a lot more information there.
Great, thank you. And then there was one last one from Friedrich Mueller stating, if I understand correctly, Corning has not studied the effect on the burner flame shape when the airflow is modified. According to the new standard, it is strongly recommended to check the flame shape to see if the equipment is running correctly. I guess that's more of a statement.
Yeah, so yeah, as I mentioned in the presentation, in the new standards, there is something on the flame shape, and it is now there because Corning's earlier work on the flame shapes. So yes, we do study the flame shapes, and because of the round robin testing that was done in last few years, it has now become part of the new test document as well.
Okay, so with that, it's important that we recognize and thank our IWCS partner sponsors who contribute greatly to the success of the Cable and Connectivity Industry Forum, both in terms of content like this presentation, as well as their strong leadership and generosity. Without that, we would not be able to bring these important technical innovations and information to you and our global audience. So again, thank you for these leading suppliers, including Corning and our entire industry for your support. So for over 71 years now, the IWCS Cable and Connectivity Industry Forum has been the recognized leader showcasing new technologies in cable and connectivity products, processes, applications. And our next 72nd annual Cable and Connectivity Industry Forum will take place live on Sunday through Wednesday, September 17th through the 20th at the Gaylord Palms and Convention Center in Orlando, Florida. So coming out of COVID, if you have some pent-up demand to visit Disney and Universal, bring the kids and learn a lot from the conference as well. So please watch your inbox, social media, and website and our website to learn more as the exciting information becomes available. Please visit iwcs.org, and we hope to have a preliminary program for this event towards the end of May, no later than early June. So looking forward to receiving those final abstracts today, and have a great weekend, everyone. Thank you for joining us.